Okay, this is our fifth lesson on Unit 9. So we did a little review at the start of the lesson on radicals, having just looked at cube roots and looked at square roots. We want to put both of them together just to make sure we're familiar with the rules. So main thing when we're doing these questions is, particularly with regard to the exponents, when we have a radical, we're going to halve the exponents. But when we have a cube root, we're actually going to divide the exponents by 3. Now, before we start going through those answers, I want to show you something that we have written on the board over here. And I think this is something that you should probably actually do before the start of each quiz and test. Write down the first 9 numbers, work out their square numbers, and also work out the cube numbers as well, because we're obviously going to need those as part of our answers. So going back to the questions, 24, that's not a perfect square, but I can split it up into 4 and 6. This is an even number, so this is good, and so is this. And the reason I say it's good is if we half this, we get the answer for that one. And if we half this one, half of y to the 10, that's supposed to be y to the 5, which I actually missed on this one. If we go across to this one, and then the square root of 4 is 2 as well. And then anything that doesn't work out goes to the end, so the radical 6 moves to the end there. Now over here for 81, x squared and y to the 9, then in 81 we can work out straight away, it's 9. Square root of x squared we can work out straight away, it's just x, because 2 divided by 2 is 1. 9 doesn't divide by 2 perfectly, so if we count up in 2s, 2, 4, 6, 8, 10 would be too high. So y to the 8 and y to the 1, and then if we just half this exponent, we get y to the power of 4, and then there's nothing we can do with that one. Now when we get to the cube roots, cube root of 8 we can work out is 2. 12 divides by 3, so we just say 12 divided by 3 is 4. And 15 divided by 3 is 5, so we can do that one straight away. This one's a bit more complicated. We can't do the cube root of 54, so we've got to think of 2 numbers at times to make 54, and one of them's a perfect cube. So from that list on the board a second ago, 27 would work nicely, and 2. 9 does divide by 3, so I can go ahead and work that out straight away, x cubed. 13 does not, so if we count up in 3s, 3, 6, 9, 12. And then I need a 1 here as well, because 12 plus 1 is 13. Same thing with 5, doesn't divide perfectly by 3, so 6 is too far, so 3 is good. And 3 plus 2 gives us 5. Then we go ahead and work out the ones we can work out, so 12 divided by 3 is going to give us y to the 4th. This one we can't work out, this one we can work out, 3 divided by 3 is 1, so z to the 1. And this one we can't work out either, because the power is smaller than the root. Using the commutative rule, all the ones that work, I brought to the front here. And then all the ones that didn't work, I combined into a single radical. And if it was the power of 1, then I simply didn't put the power of 1. Now, the first thing we actually looked at today was rationalising a denominator. Now, denominators you should be familiar with from your work on fractions. That's just the bottom part of a fraction. And you should also come across rational numbers and also irrational numbers. Now, pi in a square root number would be an example of something that's irrational, because they go on forever and ever if we were to write them as decimals. So rationalising just means make it something that's rational, something that doesn't go on forever and ever. Now, how to do this is actually quite simple. First of all, why are we doing this? Well, we're not allowed to leave a radical on the bottom of a fraction, because that looks confusing. So to get around that problem, to rationalise, you multiply the top and the bottom of a fraction by the denominator. So what do I mean by that? Well, if I have 2 radical 5, what I'm going to do is I'm going to times top and bottom by radical 5. Now when I do this, the top part, I can't actually multiply these together, or I can't simplify I should say, because one's a number and one's a radical. So it's just 2 radical 5. But I can simplify radical 5 times radical 5. Any radical times by itself is just a number. So notice we started off with something that was irrational, the square root, but we finish off with something that is rational on the denominator. We are allowed to leave radicals in the numerator though, so that's why it's just called rationalising a denominator. Now if we go to the next one, so same thing, times top and bottom by radical 3, so I have 6 radical 3. Once again, can't simplify because they're not like terms. Radical 3 times radical 3 is 3. Now this one I can actually go a little bit further on with simplifying, because 6 divided by 3 is 2. So I can leave the answer as 2 radical 3. Now for our last one, top and bottom by radical 10. So the answer is 8 radical 10 over 10. But also 8/10 simplifies as a fraction as well, because that's 4/5. So 4 radical 10 over 5 would be a good start to that question. So a fairly simple idea, but something you make sure you should practice from the test review, just to make sure that you understand thoroughly.